Assalamu alaikum students. Today we will start paper 2. Our practice will be based on paper 2 of October number 2025, first variant. And after the class, we will discuss questions of the test which was held yesterday, which was held on this Saturday. So question number, as you know, we are supposed to do the questions related to those 4 chapters, which include the stoichiometry, rate of reaction, chemical energetics, and equilibria. So we will move on where we will switch to those questions first, starting from question number 8. That will be our first question. This question is based on stoichiometry. The equation for the reaction between dilute ethanoic acid and aqueous lithium hydroxide is shown. We have this chemical reaction here. In an experiment, 20 cm cube of 0.05 mole per dm cube, aqueous lithium hydroxide is exactly neutralized by 12.5 cm cube of the dilute ethanoic acid. Which statement is correct? All right, so in this question, we are supposed to do some calculations to verify these options. First of all, the first option says the amount of the lithium hydroxide is equal to 0.05 into 1000 over 20 mole. To see if it is correct, we need to find the number of mole of the lithium hydroxide by the provided information in the statement. We now, in the statement, they have said there is 20 cm cube volume and 0.05 mole per dm cube, which is a concentration. So this is concentration, this is volume. So we will use this information to find the number of mole. And we know the formula for the calculation of mole is N is equal to C into V. N is equal to C into V over 1000 if the volume is given in centimeter cube. If volume is in centimeter cube, then we use this formula. Now, for this lithium hydroxide mole, number of moles of lithium hydroxide will be calculated by putting the values in this equation. The value of the concentration given is 0.05 multiplied by volume. The volume of the lithium hydroxide is 20 divided by 1000. So if you calculate it, the value comes out to be 0.01 mole. So this is the number of mole of the lithium hydroxide. Now, in the first option, in the A option, it says 0.05 times 1000 over 20. So if you see, this is not in line. They are not matching. They are not matching. That's why A is not the correct option. So let's see the option B. The option B said the amount of ethanoic acid reacted is 0.001 mole. 0.001 mole. How do we check it? If it is this much amount of the ethanoic acid reacted, we need to use the ratio method here. The ratio method would be between the lithium hydroxide and the ethanoic acid. So I will do the ratio on the side. Lithium hydroxide ratio the ethanoic acid, CH3, COOH. Now, according to the balanced chemical equation, there is 1 mole each of ethanoic acid and lithium hydroxide, 1 mole each. So the amount which we have calculated previously for the There's slight mistake. This is 0.001. 0.001. This is 0.001. So what we have calculated in the previous case was 0.001 mole. So if it is 0.001 for lithium hydroxide, that will also be the same mole of the ethanoic acid, 0.001. So by using the addition method, we have checked that the same amount of the ethanoic acid has reacted. Why? Why reacted? Because it is the reactant. Ethanoic acid is the reactant here. That's why it is reacted amount. So according to this, we can say that B is a correct option. But even then, I will move on to the next options to check their validity. To verify, to have a good knowledge of the whole chemistry, you must be able to validate all the options. So I will move on to the next options. I will prove that C is incorrect. We need to see that concentration of dilute ethanoic acid is 0.16 mole per dm cube. Okay, so after having said that the amount of the mole of the ethanoic acid is 0.001 mole, we have to also check with using the volume. 12.5 cm³ of dilute ethanoic acid is given. So we have the mole here, we have the volume here of the ethanoic acid. Now use these two values to check how much concentration would be there. So we use the same formula, N is equal to C into V. Now rearrange to find C concentration, that is equal to N over V. Now put the values. The value of the mole of the ethanoic acid is 0.001 divided by volume. Now here the volume is given in centimeter cube. I need to convert into the decimeter cube because I am using the mole that was calculated from the decimeter cube of the lithium hydroxide. When I did this division by 1000, I converted the volume of lithium hydroxide into the decimeter cube. And the amount of the mole calculated was also checked with the ethanoic acid. That means this value is for volume given in decimeter cube. The volume was in decimeter cube. That's why I have to convert this value into the decimeter cube. That is simple. 12.5 divided by 1000. So it will be equal to 0.0125 decimeter cube. 0.0125 decimeter cube. So divide this value by 0.0125 decimeter cube. If you do the calculation, your answer will be 0.08 mole per dm cube. However, in this option, it says 0.16, so that is incorrect. It would be 0.08. Although it's not a correct option, but we have to validate the option. The D option says the volume of aqueous lithium hydroxide used is 0.20 decimeter cube. So we can see in that question, in the statement, it said 20 cm³ of the lithium hydroxide was exactly neutralized. That means reacted completely with the acid. However, in the option it says 0.20 decimeter cube. So it is contrasting with the unit. Centimeter cube versus dm cube. They are opposite, like they are not same. So that's why D is also incorrect. I hope it's clear to everyone. If you still have any question, you can let me know in the comment section, in the chat box, or in the participation list. Number 9, the molecular formula of 4 compounds are listed. Okay, these are the formulae, which molecular formulae are also the empirical formula of the compound. If you remember about the definitions of empirical and molecular formula means the actual number of the atoms of all elements in the compound, and empirical formula means simplest ratio or simplest number, but it is actually the ratio, simplest ratio of the atoms of the element in the compound. That is a bigger formula. So if we have CH4, then the ratio between carbon to hydrogen is basically 1:4, and this is the simplest. We cannot further simplify these two values because one is already the simplest value. So we can say that CH4 is both empirical and molecular formula at the same time. It is both molecular formula as well as empirical formula. Then comes to second molecule C2H6. So C2H6 means it has 2:6 between carbon to hydrogen, but these two numbers can further be simplified by dividing with 2. Divide it with 2, also divide with 2. So you get 1:3. That means CH3 is the empirical formula. This will be molecular formula, and CH3 would be the empirical formula. So they are not same, they are different. We need to find those compounds uh, which have the same empirical and molecular formula. So 2 is not the option. The third is C3H8. So yes, 3:8. They cannot be further simplified. They will remain the same. So 3 is also in the list. And 4 is C3H6. Okay, so yes, 3:6. They can be simplified by dividing with 3 on both sides. You get 1:2. So this is not the same. Its empirical formula will be CH2. CH2 will be the empirical formula of this compound. So 4 is not in the list. So we are left with options 1 and 3. So that's why B is the correct option. I'm saying, Sarah, I'm saying that you need to calculate the simplest ratio between the atoms of the elements in the compounds. I'm doing it again. That for the CH4, there is 1:4. So 1 and 4 cannot be further simplified. It will remain the same. So if it remains the same, that is also its empirical formula, CH4. CH4 is both a molecular formula as well as empirical formula. Is it clear? But for C2H6, you can simplify 2 and 6. The 2 and 6 both can be divided with a single number 2 that gives 1:3. 1:3 cannot be further simplified. It is the simplest value. These are the simplest values. So it is 1:3. That means the formula will become CH3, 1 carbon and 3 hydrogen. So this is the empirical formula of the C2H6. And similarly for C3H8, there is 3:8. That means you cannot further simplify these two numbers with a single number. There is no way by which you can divide these two values with a single number. So this is also the same value. It will remain the same, and this will become the empirical formula C3H8. So C3H8 is both a molecular formula as well as the empirical formula. And at the last, C3H6. So C3H6 can further simplify 3:6. So 3:6 means 1:2. So this is how we get the empirical formula. Is it clear now? Okay, then question number 10. The equation for the reaction between copper oxide and ammonia is given. We have this chemical equation. Okay, the MR values are also provided. CuO mass, NH3 mass, water, and nitrogen gas masses are given. Which statements about this reaction are correct? First, it says 80 gram of copper oxide reacts exactly with 17 gram of ammonia. Here we need to understand that there are two types of the masses. One would be the molar mass, and the other one will be the stoichiometry mass. Mind it, stoichiometry masses. That means the masses of the molecules or the elements according to the moles given. According to the moles given. In other words, we can say molar masses. That also means molar masses. So according to molar masses, CuO will have a molar mass of 3 times of the MR, 3 times of its MR, which is 80. So 3 times of 80 is equal to 240. This is the molar mass of copper oxide. Similarly, the molar mass of ammonia would be 2 times of its MR, which is 17. So it is equal to 34. For copper element, it will be 3 times of 64. For water, it will be 3 times of 18. And for nitrogen, it will be just as such 28. That is also the molar mass of nitrogen. So we need to validate the options over here. It says 80 gram of copper oxide reacts exactly with 17 gram of ammonia. So 80 gram of copper oxide, consider if you do not consider 3 moles of the CuO reactant, if you do not consider 3 moles, so yes, that is correct. We can say 80 gram is there. But at the same time, ammonia has 2 moles. So you cannot justify 3 as a mole with 2 moles of ammonia. They should be same moles. If they have to be reacted exactly, that means they should have been same mole, but their moles are not same. Their moles are different. So in this way, we need to calculate their molar masses. So according to the molar masses, for copper oxide, we will have 3 times of its MR, which is 80, that gives you 240. So 240 gram of the copper oxide reacts with the 2 times of MR of ammonia, that is 2 times of 17 is equal to 34. So if if they had written 240 gram of copper oxide reacted with the 34 gram of the ammonia, that would have been a correct statement. But that is not the case here. They have not included the moles because, however, we need to include the moles in the calculation. So this statement 1 becomes incorrect according to the calculations. 240 gram of the copper oxide reacts with the 34 gram of the ammonia. The second statement says 4 gram of copper oxide reacts with excess ammonia to produce 3.2 gram of copper. Now they have included 3 substances. This is first substance, this is the second substance, and this is the third substance. Out of these 3, we have 2 reactants and 1 product. They have considered ammonia as excess amount. So if they are considering ammonia as excess, we will not include any measurement, any calculation of the ammonia to check the answer. We will only compare the masses of the copper oxide and the mass of the copper only. Because because ammonia is in excess, so we do not include it in the calculation. So let's check with the copper oxide. If they are saying 4 gram of copper oxide, then we have 80 as the MR of the copper oxide. We have 80 gram of the copper oxide. So 4 gram given means you can take the mole of this copper oxide. You can simply take the mole. Mole, with, as you know, it's a mass divided by Mole is known as, or it is calculated as mass given, whatsoever mass is given, divided by the MR or the AR of the given substance. In this case, copper oxide is a compound. So for compound, you take the MR value, not the AR. AR is only for one atom. So MR of the compound is already provided in the statement in the question. The mass of the I'm doing this for the copper oxide. So moles of the copper oxide is equal to 4 divided by 80. So the answer is equal to 0.05 mole. 0.05 mole. So 0.05 mole is used for copper oxide. And then the second substance is copper. So for copper, we do the same. Number of moles of the copper is equal to its mass divided by its AR value. Now this time you will use its AR value, which is given in the question 64. So when you do the calculation, you get 0.05 mole again. So the mass of both the copper oxide and copper have been converted into their moles, by which we can clearly say that they have exactly same amount of the moles reacted with each other. We did not include ammonia because it was in excess. So second statement is correct statement. Then third statement, the mass of water produced in this reaction is greater than the mass of the nitrogen. Now let's see this. We have the water produced in the product side about 3 moles. 3 moles of the water has been produced. So if we find the mass, it will be 3 times of the 18. So I have 3 into 18, that is equal to 54. It is equal to 54. And for nitrogen, it is just 1 mole. So N2 produced will be 28 because there is just 1 mole and N2 mass is given over here, N2 28. So yes, we can see the mass of water produced in this reaction according to the mole used, 3 moles of water. So it is greater than 28. 54 is greater than 28. So this third statement is also correct statement. So both second and third statements are correct, which means the correct option becomes D option. D is a correct option. I hope it's clear to everyone. Now, question number 11. How many atoms are present in 1 mole of argon? Now here we have the values in standard form, and we know they are representing the Avogadro's number. They are all representing the multiples or sum of the calculations in terms of the Avogadro's number, which we know as Avogadro number is equal to 6.02 into 10 raised to power 23. Now, if we have argon, we know it's a noble gas, and being a noble gas, it exists in the form of the monoatomic. By monoatomic, we mean it has only one atom in its molecule. There is no more than one atom. So by 1 mole, we also know it is equivalent to 6.02 into 10 raised to the power 23 because one mole has this much number of particles, and argon is already a monatomic having only one atom. So 6.02 to 23 will be multiplied by 1 because there is just one atom of the argon. So this value is equal to the value given in the option C. So C is the correct option for question number 11. Now, our next question, number 12. Aqueous copper sulfate is electrolyzed using copper electrodes. Which statement is correct? Now, to recall this topic, I need to show you this same topic from my notes of the IGCSE, and we jump towards the electrolysis of the copper sulfate using the copper electrodes. So here, this was the topic, electrolysis of copper sulfate with the copper electrodes. So cathode is the negatively charged electrode, anode is positively charged electrode, and here on the cathode we have the formation of the copper metal, and on the anode there is a formation of the copper ion. Cathode gives you copper metal, anode gives you copper ion, and the solution within the beaker or the cell remains blue color. It does not fade its color, it remains blue because it is continuously providing copper ions within the solution. So let's go to the questions now. The question says oxygen gas is produced at the positive electrode. So we do not find oxygen gas. Instead, at the positive electrode, we find the formation of the copper metal. We find the copper ions. Copper ions are produced at the copper, not the oxygen gas. And then the blue color of the solution gradually fades. So no, the color does not fade. It remains blue. That is incorrect. It does not fade. The option, the concentration of copper ions in the solution stays the same. So yes, the concentration is the same because it is continuously being produced at the anode, and they go towards a cathode to deposit over there. So concentration remains the same. So that's why C option becomes the correct option. And D says the mass of the negative electrode decreases. The mass of negative electrode decreases. Negative electrode is a cathode here. As you know, negative electrode is a cathode, but at cathode, the copper metal is depositing. So when something is deposited on the copper electrode or cathode, the mass basically increases. It does not decreases, rather it increases in mass. So that is incorrect. The mass increases for the cathode. That's why the D option is incorrect. So D is incorrect. Then question number 13. Which row describes the reactions during the electrolysis of the dilute aqueous sodium chloride? Electrolysis of the dilute aqueous sodium chloride. First of all, you should be familiar that dilute aqueous means it will have more amount of water and less amount of NaCl. There is more amount of water. When water is more, it means there will be more amount of the hydrogen ions as well as the hydroxide ions in the solution. So their amount will be greater. Hydroxide ion and hydrogen ions. So anode that is the oxidation reaction. Anode gives you the oxidation reaction, and cathode gives you the reduction reaction. So at anode, we would have two negative ions. One is the hydroxide ion, and the other one would be a chloride ion, because NaCl is also giving you two ions in the solution through electrolysis, sodium ion and chloride ion. So they are two positive ions. One is a sodium ion, and the second one is hydrogen ion. And they are also two negative ions. One is a hydroxide ion, and the second one is a chloride ion. In the option of anode reaction, we see there's just one anion mentioned in the D option. There is no other anion over here. Similarly, at cathode, we find there is just one cation mentioned here. There is no other option of the sodium ion. So that means that is the only correct option. So D is the correct option for question number 13. The next one is information about two reactions is given. The neutralization reaction between citric acid and sodium hydrogen carbonate is endothermic. The displacement reaction between magnesium and carbon dioxide is exothermic. Which statements about the two reactions are correct? The first option says the energy of the products formed in the neutralization reaction is greater than the energy of the reactants. Now, this statement is linked to the first point, the neutralization reaction. So, neutralization reaction is said to be endothermic in this case, although most of the time you have seen it is said to be exothermic. But for this particular case, they have already mentioned in the statement it is endothermic. So, if a reaction is of endothermic type, we need to understand what are the differences in the energy levels of the products and the reactants. For this case, I will take you to the notes again for the energy profile diagram of the endothermic reaction. So here is a endothermic reaction, as you remember. This is endothermic reaction, and the energy of the reactant is lesser than that of the products. Products have high energy. So if the reaction is endothermic, then the product will have high energy as compared to the reactants. So we see the energy of the products formed in the neutralization reaction is greater than that of the energy of reactant. So yes, that is correct. The energy will be higher. Then B option say the second option says the energy of the magnesium and carbon dioxide is greater than the energy of the magnesium oxide and carbon. Now they are linking these two reactants with the second point, this second point, like the second reaction. The second reaction is between the magnesium and carbon dioxide, and they have referred this reaction to be exothermic. So if the reaction is exothermic, then we again have to refer to the profile diagrams over here, and we see that in exothermic case, it is the reverse. Reactants have high energy and products have the lower energy, which means the magnesium and carbon dioxide would have the higher energy than that of the magnesium oxide and carbon, which would definitely be the products here. These two would be the products which are not mentioned in this point, but anyways, we can still understand these would definitely be the products. And magnesium, carbon dioxide, they are the reactants. These two are the reactants. So exothermic, the value of the energy of reactant are higher than that of the product. So second statement is also correct. The third statement says, in an exothermic reaction, the energy required to break the bonds is greater than the energy released when the new bonds are formed. So for this case, we need to look at the equation that is used to calculate the enthalpy of the reaction. And I mentioned before, this is how we basically calculate the overall energy for such a type of the reaction. In simple words, it is the energy taken in when bonds are broken minus energy given out when bonds are made. I used to make it simple in a more easier words, that is bonds broken minus bonds formed in simple words. And we remember that bonds are broken for the reactants, bonds are broken for the reactants, and bonds are formed for the products in other way around. So if they are saying the reaction is exothermic, if the reaction is exothermic, that means enthalpy of the reaction needs to be negative. It should be negative. And we remember the formula is broken minus formed. Here they are saying energy required to break the bond is greater. Energy required to break the bonds. That means if they say broken value is greater as compared to the energy released when new bonds are formed, they mean to say formed value is smaller. Then in this case, the value will be positive, not negative. The value for this, according to this statement, will give you positive value. However, for exothermic reaction, the enthalpy value is negative. So they are contrasting with each other. That means the third statement is not correct statement. That's why only one and first and second statements are correct, which means B is a correct option. Then 15, the reaction pathway diagram for reaction is given. Which row identifies energy, activation energy, and the enthalpy change for this reaction? So again, we need to look at the energy profile diagram along with their labels. So that reaction will also tell you the labels. So you can see over here, EA is the energy difference from the reactants to the top of the peak, and delta H is the energy difference from the reactant to the product. From reactant to the product is delta H, and reactant to the top of the peak is EA. So coming back to the question, one is a difference from reactant level to the top of the peak. That means one is the EA value. So it is EA. And second is reactants to the products. This is a reaction pathway diagram of the endothermic. This is for endothermic. So these are the levels of the product. So reactant to the top of the product is 2, which is delta H. So 2 will be delta H. So that means A is the correct option. Then question number 16. Hydrogen peroxide solution decomposes very slowly at room temperature to produce oxygen gas. This gas forms a rising foam when liquid detergent is added. 5 test tubes are filled with hydrogen peroxide solution. A drop of liquid detergent is added to each one. Different metal oxides are added to 4 of the test tubes, and the height of the foam formed after 1 minute is measured. The results are given. There are different combination of the metal oxide used, and in this case, in A option, there is not a single metal oxide used, and the height of foam has also been mentioned. That shows how much the reaction has carried out. Which conclusion can be drawn from these results? So, if we look at here more deeply, we can understand that the reaction is being carried out is being carried out by the decomposition of hydrogen peroxide, and it is producing oxygen gas. That oxygen gas is forming the foam. So the more amount of the oxygen gas produced means there is a more decomposition of the hydrogen peroxide. That is indicated by the level of the foam, which is the height of the foam. So A option says metal oxide do not affect the rate of this reaction. That is incorrect. We can see that if there was no metal oxide versus these metal oxides, they are definitely affecting the rate or the reaction, because all these heights of the form are calculated after a time of 1 minute. So rate is definitely being affected by the presence of these metal oxides. So A option becomes incorrect. They are different heights. Although there is not a difference between aluminum oxide and no metal, but for the other metals there is a difference. B option says all metal oxides increases the rate of the reaction and act as a catalyst. It says all metal oxide. But here, aluminum oxide is not affecting the rate of the reaction because there is clearly no difference between no metal oxide and aluminum oxide. So we cannot consider aluminum oxide here. And C option says manganese oxide is the best. Manganese oxide is the best catalyst if the four metal oxide is tested. So if we look at here, manganese oxide is giving the highest height of the form, 5.4. 5.4 is the highest height of the form. That means it is the best catalyst. Catalyst what increases the rate of the reaction. Increases the rate of the reaction. So much amount of the form is produced by manganese oxide. So that's why C is the correct option. Anyways, we also validate the D option to see why is it incorrect. D option says only transition element oxide increases the rate of this reaction. So uh, only transition element oxide increases the rate of the reaction. But here we see calcium is not a transition element. Aluminium is already not included in the list, but calcium is not the transition element. Even then, it is increasing the rate of the reaction because the difference is there. There is a difference between non-metal oxide versus calcium oxide. So we cannot say it is only the transition element. In fact, these different combinations have their different effect on the rate of the reaction. Then question number 17. Which equation represents one of the reactions in the contact process? So if you remember the contact process, what was that? It is the reaction to form the sulfuric acid. And in that case, we have the reaction between the sulfur dioxide. We have the sulfur dioxide reacting with the oxygen gas. So both should be in gaseous form, sulfur dioxide and oxygen, they should be in the gaseous form to make the sulfur trioxide. All the other options are incorrect. There is no SO3 in the reactant. And the B option, SO3 is produced but in the aqueous form. That is also incorrect. It should be in gas state. So A is the correct option. Then question number 18. The ionic equation for the redox reaction between acid manganate ions and iodide ions is shown. Which row show the changes in the oxidation number for manganese and for iodine during this reaction? So here we have the calculations required to check the oxidation numbers. I will do this for manganate ion because it's the only compound. Oxygen already has a -2 for one atom, and for four atoms it will be -8. The overall charge on the whole ion is -1. That means the plus charge on the manganese should be +7. +7 and -8 gives the overall charge of -1. So manganese is present on the reactant side as +7. So we have C and D options. And on the right side, it has been converted to which state? +2. So +2 is on the right side. Then, according to the iodine has been changed from -1. This is -1, the only negative ion with one atom. This is atomic ion. So monatomic ion has -1 charge, and it is converted into I2 molecule, diatomic molecule. And we know it is the elemental form having zero oxidation state. So it is converted to zero. So there are 4 ticks in the C option. And then our last question, according to the syllabus. In the Haber process, nitrogen and hydrogen react to form ammonia. The forward reaction is exothermic, which changes in pressure and temperature increases the yield of the ammonia. Now here we need to understand how there is the effect of the temperature, pressure on the amount of the yield. So that has to be revised from the topic of the equilibria. We remember if we increase the temperature for the endothermic reaction, we have already studied this effect of the temperature on the position of equilibrium. That if there is an increase in temperature, it makes a reaction towards the endothermic direction. If you increase the temperature, it shifts the equilibrium towards the endothermic direction, and it reverses for the exothermic reaction. So this is the only factor which you have to remember, which you can apply on all the other combinations. So I will take to the question. The reaction is exothermic. So for exothermic, and we have to increase the amount of the ammonia. You have to increase ammonia. So what we need to do, we must have a decrease in the temperature. To increase the ammonia, it should be decrease in temperature because reaction is of exothermic. So we decrease the temperature, and the effect of the pressure. The effect of the pressure was to do with the number of the moles. So again, if we look at the notes again, the effect of the pressure was related with the number of the moles. For example, here there were 3 moles on the reactant side and 2 moles of the gas state. So if you increase the pressure, there will be more amount of the SO3 produced. Increasing pressure, by increasing the pressure, SO3 will be produced more because there are less number on the product side and less amount on the product side and higher amount in the reactant side. So coming back to here, we see there are 2 moles of the ammonia and 4 moles of the reactant. So increasing the pressure would shift the equilibrium towards the product side to increase the yield of the ammonia. So in this way, the correct option becomes the C option. C is the correct answer here. So in this way, we have attempted all the questions related to the chapters which are currently covering. So that's it. If you have any question, please let me know. All right, students. So if you need any query to be resolved, or if you need acquire my notes of these chapters, you can reach me out on my WhatsApp number or comment section or my Instagram account. That's all, friends. Till our next class, take care and bye bye and Allah Hafiz.